SREB powerful mathematics practices include 5 major indicators. This video will focus on one of those indicators, utilizing questioning and feedback for deeper understanding.
How do you know those lines are parallel? It doesn't tell me here.
If we don't challenge our students to get down to the deepest understanding, we can't expect them to turn around results. We want them to be able to not just regurgitate formulas to us. So when you're planning a lesson, and even broader, a unit, I think it's extremely important that one of your major emphasis is on your questioning. And if you will take the time in the beginning, on the forefront, and target things that you anticipate are going to be misconceptions that you need to address, it's going to make you so much more prepared.
I want you to write on your whiteboard individually what you believe or feel that the term mathematically similar means.
The teacher asks targeted questions that require students to analyze, synthesize, and predict in order to advance their sense-making for a deeper understanding of mathematical concepts.
In my intro, I wanted, number one, to get them thinking, and then for them to have to be able to put it in words. If they can put it in words, then typically they truly have a stronger understanding of it.
Avery, if you will start for me back here, hold your board up, and tell us what your definition of mathematically similar is.
So I said a shape has the same angle and shape, but are different sizes.
Okay, so shapes that have the same angles and
They're the same shape.
they're the same shape, but are different in size. Okay, Logan.
All sides are equal, like on a triangle, all sides would be 60 degrees.
Okay, so are the sides 60 degrees or?
The angles.
The angles, there you go. As I walked around, I knew that's what you were, or I thought that's what you were thinking. I just wanted to clarify there. So that's why I asked you to share that with us, because that's a common misconception that we sometimes have, guys, and that's what today's about. We're going to clear up some of those misconceptions that we have as we're beginning similar figures here. We're taking a look at what are some things that we sometimes get confused with. Okay, Daniel, would you mind standing up and sharing yours, please?
Okay, so similar shapes, two shapes that aren't really like the same size, but they have the same like shape and everything, they have the same angles.
Okay, so the same angles. What do we mean when we say same angles? What's another mathematical term we could use?
Congruent.
There you go, congruent angles, very good.
I feel like the whiteboard part is just kind of like an icebreaker just to get us into the lesson.
Honestly, when we started out, I didn't really have a good understanding about what, because our main lesson was what's similar, what it means to be similar, and I had no idea, in the beginning.
That'd be 110.
So this whole thing really just kind of cleared everything up for me about what it means to be similar.
Yesterday we completed a task, our pre-assessment, called Puzzling Triangles.
Teacher feedback identifies student misunderstandings and emphasizes a change in conceptual understanding among students.
I took a good look at your work and I grouped you based on other students that thought like you thought.
I had noted that this was a specific question I wanted to address with so-and-so's group, so that I had a reminder right there in front of me when I came to them. If they were working on a particular group of triangles and they were trying to decide similarity or not, was what they were discussing right then the same mistake that they were having, or the same struggle, that productive struggle that they were having on their prior activity? And if it was, that's just a perfect time for me to say, okay, let's refer to our feedback question.
I'm going to be placing on your desk some feedback questions that I wrote based on your responses to the pre-assessment that we did yesterday. As you're working on this, I may refer back to the feedback questions. I may point to those. And also I want you to use those to help one another think through some of these. If you get stuck on one, take a look at these questions and ask yourselves and each other what you think about these questions. Okay, you may continue to discuss. So when you change this to wherever you think it should go, make sure you put your justification on here. Very, very similar to how you told Peyton. Great job.
When she comes around and she doesn't give us the answers, the feedback questions are questions that she would ask us when she came around, so it really just engages me, and if I'm stuck, it helps.
So would that one be similar?
Yeah, it's similar.
Which are the alternate interior angles created by the parallel lines in your transversal?
When the teacher asks higher order questions or provides feedback, he or she always provides appropriate time for students to process and engage in a productive struggle with the math.
Avery, are you following me?
Yeah.
So what do you think you need to do now? Talk to your partners.
What are you thinking? I don't know.
Do we have another pencil?
I do think that it's extremely important to not give students the answer. If the students can arrive at the answer on their own, several things are going to happen. They're going to own that, and that gives them such confidence when they can be the one that came up with the solution, and even more confidence when they can explain it to their partners. And when they see their partners' light bulbs go off, that's fantastic.
And this
Then
one.
that would have to be
So it's 70,
because they're alternate.
and then that's an alternate to that one. But we don't know the measure of those two angles. I mean, we.
Focus on which pencil is your transversal. Sometimes you have that sense of, I'll be standing here for 10 minutes. And that's when you have to step back and you have to say, I will be patient. I will point out certain aspects that might be correct and redirect them if they need so.
If you turn that.
The more you do it with the students, the more accustomed to it they get. They actually now very seldom expect me to give them an answer. And they very seldom now will say, is this right? Eli, what color pencil is your transversal?
Blue.
The blue one.
So I'm guessing 70 and this 70 and that 55 are the alternate interior angles, maybe?
Which angle in the top triangle is created by a parallel side and a transversal? Just point to it.
No.
Yeah,
It would be this one in the corner.
Brianna, explain to Eli why.
Because here's your parallel line, and then here's your transversal, and this angle here is created by both of these.
Oh.
And then it's the same way for this one down here in the right-hand corner.
Those have to be.
So they have to be equal or congruent.
So why don't you mark them as congruent in whatever fashion you want. Now remember we said how we do in the United States may not be the same as others, but as long as you three understand what you're marking it as.
Without prompting, students ask questions of one another about their reasoning.
Well, if you flipped it, aren't they like, when you like flip it on top of each other?
And it would, yeah, it would look like
So that would be 70. So that would, on a bar, that would be 70. Because you wouldn't flip it over.
There is enough information there.
Wait, are we still keeping this as similar?
Yeah.
I found something different. I found it was not similar because, like, from what they said, this would be 70, 70, and 40, and then 70, 55, 55.
How is that 55?
Why is it 55?
If these two sides are the same, then these base angles have to be congruent. So then both sides would be 70 and this would be 40.
Yeah, but if you're
Yeah,
going
that's
by your
absolutely
base
right.
angles being congruent, are these your base angles here, or are these your base angles?
Yeah, it doesn't tell you what your base angles are.
I took it as this because it would these two or so then it would be these two.
Basically, this one is like, it's gonna be like 70. Like these are the same interior angles, right? Like they're alternate interior angles.
Yeah.
So that's 70. So that one's wrong, and then you have like I forget which way she had it. It was like either 70, 70, 40, and then 70s, 55, 55, or like 70, 55, 55, so whatever. I forget.
70.
So this one's 70.
Yeah.
Let's just start over. Because if not, we're gonna get confused.
So,
And it's like it's not the sides are.
70 and 70. And then,
So that's not 70. Wait, no, maybe. Yeah, one of those is 70. Yeah, that's 70. That'd be 70, and that would be 40, and that'd be 55, and that'd be 55.
okay. So then that would be not similar.
Not similar.
Okay.
Bring your poster up with you as a guide there if you'd like to do so. Remember, what's most important is that we understand our explanations for why particular angles are congruent or why they're not congruent.
The teacher asks questions in ways that require all students to formulate a response and intentionally selects students to answer questions based on an instructional strategy.
The only other angle to get 180 would be 55 here. Make two triangles similar.
Okay, how many groups had A as similar? Excellent. If you did not, I want you, if there's any part of that you didn't understand, please ask, and Devin or his partners here can explain to you where those angles were found. So now, if Hannah and Peyton will come up, we're going to look at H now. H was one that I noticed when you were in your partner sharing, when we were going around to the different groups. Numerous groups ended up moving H. And that's why I asked Hannah to explain this one, because at first, a lot of you automatically put this where?
Not determined.
Not determined. More than half of you put this in not determined. So, go ahead, Hannah and Peyton.
Okay, at first we had it under not determined because we had no numbers given. None of the angles were there. But that's a vertical, so that means those two are congruent. Alright, Hannah, take it from here.
And then Q and T, they are alternate interior angles, which makes them equal to each other as well. And then so are P and S. And they are also parallel lines, which make them equal to each other, which would be similar.
Okay, so one more question. Why are angles P and angle S congruent?
Because they're alternate interior angles.
Created by what kind of lines?
Parallel.
Parallel lines and a, what do we call?
Transversal.
Very good, very good. That is the one thing about mathematics. You're continually pulling back the facts that we have learned previously and basing our new theorems on that. As you look at these, believe it or not, you're proving theorems that we're going to be exploring in further depth in the days to come. We're going to be looking at why is it true that if two of the angles are congruent in one triangle and two of the angles are congruent in the other triangle, why does the third angle have to be congruent? That's a theorem. And we're going to take a look. You have proved it today. Now, before you tell us what you have now, Megan, will you tell me what you had originally?
Like we put this would be 90 and the triangle equals 180, so we put, and 90 minus 180 is 90. So we had 45 right here and 45 right here. But since these lines are parallel, you don't know if these two angles are congruent. So this is a transversal. Then this angle and this angle are alternate interior angles. So they're the same. And then since these two angles and these two angles are the same, these two are the same.
Excellent.
I hope it helped people that watched it, because I know it helped me. When you look at the problem, I definitely, the first time I looked at it, I did not I was like, okay, that's not to be determined, there's no numbers. But now you look on it and you really see how it's similar.
Do you know what also is true now? Think about your different kinds of angles.
If she just told you the answer right off the bat, then I know I would take advantage of that, and I know most people would. So for her to ask questions to push us to think for ourselves, that's what I mean by it helps me.
And then she makes sure we understand, and it really helps.
As emphasis is placed on deeply understanding and implementing the concept of powerful math practices, ask yourself the question: to what extent are questioning and feedback used to deepen student understanding in your classroom, your school, and your district?